Hey guys, it's Miss B again. In this video, we're going to continue on with what we've been doing with factoring trinomials. So far, we've done one on factoring trinomials with a leading coefficient of 1, which means it looks like x squared plus something, x plus something. And then the last one we did was factoring with a leading coefficient that's not 1. So it'd be something like 2x squared plus 3x plus 5 or something like that. Okay. So today, with this one, what we're going to talk about is factoring when there's a common factor you can pull out before you even look at, breaking it down into its two binomials. So that's kind of the last step in this. What are the things we look for when that happens? And, this is kind of the same thing we do in class. One day we spend on one thing, one day we spend on the next, and we always add. So now let's look at, let's get started. So here we go. Now remember, in the other two videos, I always said the first step was the question, does it have a GCF? Does it have a greatest common factor? Well, up until now, the answer has been no. But what happens if it does have a GCF? Okay, so let's look at it. Let's take it out. So what do I mean by take it out? If my problem is 15y squared minus 18y minus 24, does this have a common factor? Does this have a greatest common factor? Well, let's look at this. 15, 18, and 24 can all be divided by 3. So I'm going to take that out first. So now I have 3 times 15y squared, oops, not 15y squared, 5y squared minus 6y minus 8. Now, is there a common factor in this? There's not. If I identify my A, B, and C, because I'm going to need them, here's A, here's B, and here's C. Now, as I work through this problem, this 3 out here, of this GCF of 3, isn't going to go away. It's going to stay there as part of it, but it's just going to kind of hang out on the outside. It's there, but we're done with it. It's just going to hang it out for the rest of the problem. Now, we're going to multiply A and C to then find what we need to factor. So now I have 5 times 8. Well, 5 times negative 8 is negative 40. So that's the number we're working with. Why is that negative important? Because it kind of drives what goes here. Because I have a negative here and a negative here. When I'm looking to break this apart, I want a positive and a negative. Okay, now I need factors of 48 that give me, that either add or subtract to this middle term. So I need factors of 40 that add or subtract to give me negative 6. So I'm going to write this over again so I can see everything. So I've got negative 40, which means I'm going to have a plus and I'm going to have a minus when it comes down to it. Numbers that multiply together to give me 40. 1 and 40, 2 and 20, 3 won't go in, 4 and 10, or 5 and 8. Now, because this term in the middle is negative, I want the larger of these two to be negative so that when I do my adding, I'll get a negative as my answer. I'm looking for a negative 6 as my answer. 1 minus 40 is negative 39. That's not going to work. 20 minus 2 is negative 18. 4 minus 10 is negative 6. Okay, so right here, this is the one I want to use. I'm going to take the center term and I'm going to break it apart. So now I have 3 times 5y squared minus 10y plus 4y minus 8. Now, why did I put the 10 with the 5 and the 4 with the 8? Well, 5 and 10 are both multiples of 5, so it's going to be easier to find something they have in common to pull out. That's why I moved it around. I could have done it the other way and it would work, but here, go ahead and if you find things that you can group together easier because you can already see something they have in common, go ahead and do that. So now let's look at my first two pieces. The 3 is still there. Write a bracket because I'm still dealing with finding that inside. 5y squared minus 10y. Well, 5 and 10 can both be divided by 5, and y squared and y can both be divided by y. What that leaves here is a y, because 5y squared divided by 5y leaves a y behind. Negative 10y divided by 5y leaves one with negative 2. And we'll look at the next part. 4y minus 8. Well, 4 and 8 can both be divided by 4. 4y divided by 4 leaves a y behind. Negative 8 divided by 4 is a negative 2 behind. Now look just inside the brackets. Inside the brackets, do we have anything that they have in common? 4y, I got y minus 2 here, and I've got y minus 2 here. So now, inside that bracket, I've got a y minus 2 that can come out, and then I have left 5y plus 4. Now it's completely factored. Do I need these brackets? Not absolutely. But they kind of help come in handy and kind of help me see things and sort things out. It still follows the same basic ideas that we've always been doing, except we just added in this little 3 out here that makes checking it a little bit trickier. If we wanted to check our work, we could always go back in, do our FOIL method here, first times first, outer times outer, inner times inner, and last times last. And then once we have all that, distribute our 3 across. So it still has some of the basic processes the same. That basic process hasn't actually changed since our first video on this, since we factored with a leading coefficient of 1. You just always have to be careful. If they just put a trinomial in front of you, run through your checklist. So I'm going to put a trinomial in front of you. Let's run through our checklist and see if we can factor this. So I've got 32w squared minus 16w plus 2. All right. Does it have a GCF? Well, each of these numbers is even. So it has a GCF, we know, at least of 2. If I take the 2 out, 32 divided by 2 is 16. 16 divided by 2 is 8. And 2 divided by 2 is 1. So there we go. I've taken the 2 out, and what I have left behind. Is there a GCF here? Maybe with 16 and 8, but 1 thrown in there, we don't have one. Now, this is a trinomial with a leading coefficient that's 1. So we do what we did in the last video. First number times last number. 16 times 1 is 16. So now I need numbers that multiply together to give me 16 and add together to give me negative 8. Well, is this going to be a positive and a negative, or 2 negatives, or 2 positives? Here's your hint. This right here is positive. This right here is negative. If the ending's positive, both our pieces are the same, sign-wise. This in the middle tells me, because this is negative, both my factors are going to have to be negative when I come down to my adding and my subtracting. So let's now look at what numbers give me 16. Either have a 1 and 16, oops, 2 and 8, or let's see, 4 and 4. Because I decided they both have to be negatives. What's going to happen? Well, negative 1 minus 16 is negative 17. Negative 2 minus 8 is negative 10. Negative 4 minus 4 is negative 8. This is the one I was looking for. So I'm going to break this -8 into its two pieces. Now I have 2 times 16w squared minus 4w minus 4w plus 1. That feels kind of weird, but that's following our process. So let's look. Do these two have anything in common? Well, 16 can be divided by 4. So that means I'm going to take a 4 out. Both of these have at least one w, so I can take that out. 16w squared divided by 4w is 4w. Negative 4w divided by 4w is -1. Because a number divided by itself is 1. A variable divided by itself is 1. Let's look at the other one. Negative 4w minus 1. Do they have anything in common? It doesn't look like it. But look, over here I have a positive 4, and right here I have a -4. What would happen if I divided each one of these things by -1? Negative 4w divided by -1 is 4w. Positive 1 divided by -1 is -1. Now, within my brackets, I have found something they have in common. They both have 4w minus 1 in common. So now I can take that out. And I can write down what I have left. Now, this one is unique, and what do you notice about these two? They're exactly the same, and that can happen sometimes. Now, how would I write this in its simplest form? If I was looking at this on a test, on a multiple choice test or something, are they going to have it like this? Or if, say, we're on our SOL test and it asks you to type out your answer, are they going to have it like this? Or are they going to acknowledge the fact that these two are exactly the same and rewrite it as 2 times the quantity, 4w minus 1 squared? You could see it either way. The most mathematically correct way to write it is this one, because you're acknowledging that you have 2 of the same thing. Now, next one, I'm going to let you work by yourself. Okay, I'm going to put it down. I'm not going to give you 5 minutes of video time. What I'm going to ask you to do is I'm going to ask you to pause your video that you're watching, work out the problem. Once you have the problem worked out, or try it, and we all don't always succeed the first time we try by ourselves. Once you've tried it, start the video again and see if your work matches my work, okay? So here's our problem. 10k squared plus 75k plus 35. Now write this down on your own paper. Pause the video while you work, and when you're finished with your work, come back and check the video. So let's look at this. 10, 75, and 35 are all multiples of 5. So that's what I'm going to do first. I'm going to take out the 5. 10 divided by 5 is 2. 75 divided by 5 is 15. I think, let me double check. Yeah, 15. 35 divided by 5 is 7. Now, do I have a common factor in this? No, I don't. So now I'm ready to factor my trinomial with my methods I've already used. 2 times 7 is 14. So I want 2 numbers that multiply together to give me 14 and add together to give me 15. Okay? So my possibilities for 14 are 1 and 14 or 2 and 7. 1 plus 14 is 15, or 2 plus 7 is 9. So I'm going to go with this one. So now we're going to break our 15 apart. This becomes 5 times the quantity, take k squared plus 1k plus 14k plus 7. Okay, now let's look. First two terms, do they have something in common? Not on the number side, but they do on the variable side. I can take out AK from both of those and leave 2k plus 1. Now we'll go to the other two. Well, 14 is 2 times 7, so I know I can take a 7 out. 14k divided by 7 is 2k. 7 divided by 7 is 1. Right. Now I've pulled out common factors from my mini groupings. Now let's look at what we have. 2k plus 1 in the first half, 2k plus 1 in the second half. So I'm going to pull that out. And what do I have left behind? I have k plus 7. Now you'll notice this time I wrote it without the brackets, and that's something that mathematically we're going to do anyway. Eventually those brackets that we use just to tell us that we're working on that small part, we're going to take out because we run out of, things to use, and we don't want to clutter our problem up with more parentheses and brackets and grouping symbols than we absolutely need. So I'm going to put one more example here for you all to do. Same deal as last time. I'm going to put the example down on the page, and then I want you all to pause your video, work the problem yourselves, and then start the video back and check your work against mine, okay? Does it have to look exactly like mine? No, but does your process and your thought have to follow in the same idea? Yeah, because there's no two people approach the same problem the same way. So my husband and I are good examples. We're both math teachers. You set a math problem in front of us, he and I are going to work it differently. Now, should we come up with the same answer? Yes. Should we be able to explain our processes to each other? Absolutely. But sometimes the little pieces on the inside are different between people. Okay, so let's look at our last example of the day. We've got, I have a good one here. 6a squared plus 9a minus 27. Okay, write this down on your paper. Pause the video, work the problem, and then start the video back. All right, so now that you started the video back, and I didn't waste 5 minutes of dead space so you could get it done, let's look at what we have here. 6, 9, and 27 can all be, well, they can't be divided by 2 because they're not even, but they can all be divided by 3. So we're going to pull out a 3. 6a squared divided by 3 is 2a squared. 9a divided by 3 is 3a. Negative 27 divided by 3 is negative 9. Now, in what we just created, is there a GCF in this part? No, there's not. We've taken care of that. So now I'm going to do first times last, 2 times negative 9. I'm going to get negative 18. Negative at the end, positive in the middle, means I've got to have one positive factor and one negative factor. Numbers that multiply together to give me negative 18, add together to give me positive 3. Well, 18 is made out of 1 times 18, or 2 times 9, or 3 times 6. Because this number in the center is positive, the smaller factor is going to be the negative one. Okay? Now if I check to see what they add up to, negative 1 plus 18 is 17. Negative 2 plus 9 is 7. Negative 3 plus 6 is 3. This is the one I want. Now let's break apart our 3a. 2a squared plus 6a minus 3a minus 9. put the evens together and the threes together, the multiples of threes together. You didn't have to do that. You could do it the other way if you wanted to, okay? So now let's look at these first two terms. I have 3 times, all right, these are both even numbers, so they can be divided by 2. They both have at least one a, so I can take one a out. It's going to leave an a here, because 2a squared divided by 2a is a. 6a divided by 2 is 3. Let's look at the second half. Negative 3a minus 9. Well, both of these are negative, so I could go ahead and take out a negative. 9 can be divided by 3. So negative 3a divided by negative 3 is a. Negative 9 divided by negative 3 is positive 3. Now that I've broken down my two pieces, I'll look at this answer, and I'll notice that I have a plus 3 in both of these. So now I have 3 times, I've got my a plus 3's, and what I have left is 2a minus 3. Now, do I need these brackets? Not necessarily. So I could rewrite my answer as 3 times a plus 3 times 2a minus 3. Now, that's it. Guys, you just have to take it in little pieces. I know it seems huge and scary, but it's not. Just remember, you look for your GCF. Then you do your first term times your last term to get the number that you're trying to factor, kind of get the pieces of. Once you know what that is, then you find its factors, and then you look at those factors and decide which one will add up to give you the piece in the middle. Then you put those two factors back in the problem, you break up that piece into the middle, into its two pieces. And then you take that set of 4 terms, break it in half, and just work in small chunks. Factoring is all about breaking it into small chunks where you can find common pieces, and then being able to put all those pieces back together. Now I'm going to give you one more to work. And just like in the last video, I'm not going to tell you what the answer is. But if you think you know what the answer is, go ahead and put it in the comments or email it to me for those of you that know my email address, for those of you that are my students. Either put it in the comments or email it to me, and we'll see what we can get. So our very last problem, 16a squared minus 32a plus 24. Once you have that factor, put it in the comments. Tell me what you think it is, and I'll let you know if you're right or not. Y'all have a great evening. Stay safe, be good, and I'll talk to you later.